Today's focus is on a high-performance fuel injection pump carrying part numbers 0445020195, 0986437512, 5,801,486,599, 504,388,756 intended for use in Stralis, Trakker, and Holland T9 heavy vehicle engines. This is far more than a generic replacement. This pump plays a critical role in timing, pressure regulation, combustion efficiency, and overall engine reliability. Throughout this presentation, the aim is to clarify how to evaluate, install, test, and optimize such a unit, and to highlight the key criteria that separate a dependable pump from a liability. Let's begin by exploring why this component is so central in diesel engines of this class. The fuel injection pump is responsible for pressurizing and metering fuel to the injectors, coordinating the injection timing precisely with the engine cycle. Any deviation in pressure, timing, or volume can ripple into diminished performance, excess smoke, higher fuel consumption, or even internal engine damage. For trucks deployed in demanding use, long hauls, variable loads, extreme conditions, the tolerance margin is tight. The particular pump under discussion, denoted by those multiple part numbers, is engineered to interface with the Stralis, Trakker, and Holland T9 platforms across diverse markets. That breadth of compatibility is an advantage. It means spare parts, calibration kits, or service support may be more readily available. When a unit like this arrives, the first step is inspection. Start with external surfaces, check all ports, bolt patterns, and mounting interfaces. Look for signs of machining flaws, misalignment, rough burrs, or casting inconsistencies. Even a new pump should be flawless on the exterior. Any irregularity might hint at mishandling or a subpar casting. Next comes internal examination, if accessible. Components to check include the rotor, plungers, sleeves, seals, and internal bores. Precision machining and tolerance matching matter. Any scoring, pitting, or wear in these areas compromises pump performance. If a rotor or plunger is out of spec, that leads to pressure variation, leakage, or loss of volumetric efficiency. Calibration is another vital dimension. Some pumps come pre-calibrated, others require fine-tuning at a workshop with specialized equipment. The calibration must match the engine's required pressure curve, injection timing map, and flow profile. Even a slight mismatch can degrade performance or cause errors in engine management. The mounting and port layout must also align exactly with the host engine. If the inlet, outlet, return, or mounting flange do not precisely match, using adapters introduces risk, especially in high-pressure systems. Adapters can introduce additional dead volumes or leakage paths. Once installed, the system must be primed and tested before full operation. Fill the pump, purge air, and use a separate pressure gauge to verify operating pressure under no load and under simulated load. Observe for leaks, unstable pressure, or smoke during initial runs. Choosing this pump over alternatives depends on several factors. Its multi-code compatibility ensures flexibility across markets. Its application to well-used platforms like Stralis/Trakker/T9 brings familiarity in service shops, and if it comes from a legitimate OEM or high-quality aftermarket source, the cost-to-longevity ratio is compelling. Yet, cheaper replicas are tempting.